Yeah, perfect. Okay, let me share the slides. So, second class of information management. Today, so last week we were looking at this one to show kind of the full data science cycle. So we have, we talked a bit, we looked a bit at visualizing the data last week. Here we also imported it. So we managed to get the data into the programming system, so R in this case, and we focus on visualizing the data. Kind of to give you the full picture. So we worked on getting R to work, getting RStudio to work. How do we create a project? How do we manage to keep everything together to be able to make these things reproducible so we can redo them at a later stage? And we worked with a nice clean data set that was ready for us just to create visualizations directly from start. However, most times that's not the case. So most times we get the data and we'll have to do some kind of data cleaning. So preparing the data to get into the shape and having the variables that we want for us to work with, to communicate. So this week, we'll focus solely on this stage, so the transformation stage. So we'll import some data. We will transform it. So we'll look at calculating new variables, filter out only the parts that are relevant that we are interested in. We will look at how we can summarize data to get to summarize tables presenting the data that we are actually interested in. So these are the things that we will look at today, and we will work with this data set today. So if you want to follow along, I will copy this one into the chat when we get started. So you should be able to just download the data and go along as we go through this. What we actually will be looking at for transforming data is the dplyr package, which is so remember that we have a bunch of built-in functions in R, which are these functions is what changes things. Remember, they have an input, they do some kind of transformation, and they have an output. Today, and there's a bunch of these functions within R itself, but there are several things. So if you want to do something else that's not possible to do directly in R, what you can do then is install one of these packages. So remember, last week we imported the readr package. We imported the tidyverse to get several of these packages in. Today, one of those packages that are within the what is called the tidyverse is the dplyr package, which focus specifically on working with this data. So we'll look at a couple of different ones of these ones, go through them, go through some good practice to make sure your code is reusable at a later stage and extendable and so forth. So to jump straight into it, I have some data here, which I promised to share with you. So anyone that wants to join in. And we have my Zoom window.
Could you please copy the link in order for us to download the data on the chat, maybe?
That's the plan. I'm just trying to locate my Zoom meeting window. Okay, just give me a second. This. Okay, now you have the data. So we will be working one more day with MBA data. So we'll keep a little bit similar style to the data we had last week, just to focus on the functions, on working with this data. So first thing we'll do, same as always, when we start something new, we open up RStudio. We create a new project. For whatever reason, it's not the fastest, my computer today. We create a new project. If you created one previously, that you will by default have it as the primary option where to put it. So I will try to keep all my projects within the project folder. So I choose that as a folder, and then let's call this one Information Management Class 2. We'll create this project, and now remember, first step was to get the data in here. So we will need to get the data into the same folder that where we have the project. Remember, this file, the rproj file, is the one that defines where does this project start. So where, in which folder do we count everything from? So what we can do is we go to our browser where we can browse the files, go into our, find our project, and here it is. So here, or remember that we can go this way. We have the file pane here where we can just check which files we have in the project. But from here we can also jump directly, open folder, new window, and we'll get to the same place in Finder, or if you're on Windows, the file browser. So we will get our data in here, and now as you see here, it's available for us to use within this project. Same as last time, we create a new script. So we have a file where we save all the code we'll be using. And good practice is remember to save it directly from the start. So we'll call this one data cleaning, for example, because we want to specify here that we're working with cleaning up the data. Save this, and now again, first step is always import the data set. So to do this, remember that what we did last time is we load the tidyverse, which is couple of different packages. As you see here, the one we are working with when we import data is the readr package, which has a couple of functions for getting data that we have in a file, in this case the CSV file, into the environment so we can work with it. The other one is dplyr here, is the one that we will focus on today. We could load these packages by themselves. So loading all of these packages together. So the tidyverse is basically a package that the only thing it does is load more packages. And since these packages are often used together, we could load all of them together. But we could do this by hand. So we could instead say library read R and load only the package to read in the data. The same thing we could do library dplyr to get only the package with the functions to work with the data. So that's perfectly fine. Just to show you here that the actual packages we're working with are these ones. Once we load it, now we need to read the data. And again, it's we still work with CSV files, so comma separated values files. So we will read CSV. And again, the biggest help here to remember all the arguments. So remember that the arguments is the things inside the function that defines how the function should work, what the function should do. A lot of times we don't actually remember what this is, what the arguments are. So what we can do then is we just do a question mark before, command enter to read it, and here we get the help pane to read about it. And we can see here that the first arguments tend to be the more important ones. We see that the first one is file, which we could guess then, which we could then guess is the file that we will read. We could continue down, checking file, either a path to a file, a connection, or literal data. So path to the file is the one we will be working with. And remember the second thing, when we have arguments early in the function that are more or less the same arguments every time, instead of having to manually type out the argument name each time, what we can do is just to put it directly in here without naming it. So without putting data equals, we just write directly the path to it, which again, we always count from where the project starts. So we don't need to say that this one is in my home file, then inside projects, then inside the IAM class. We start counting from here. So in this case, it just lays directly here. So quotations, MBA player data.csv. And we want to save this. Remember, we want to save this to an object, because if I now just run this, it looks really good. We can see here it executed the function. We can see information about the importing process. We can see a preview of the data, but we don't have any way to work with the data. So remember, that's why we need to save things assign things into an object. So here we might want to call this player data option dash. I just noticed now I haven't turned on the keystrokes like this. See if we get this working. Perfect. Now, again, remember down here, you can see if I use shortcuts. So we want to assign this into the player data object. So now when I execute, command enter or control enter, we can see in the environment pane that we actually have the data here. First step, always when we have external data that we work with, that we get in, is make sure you get a view of the data. Look at the data. Does everything look okay? Do we understand the variables? Is there a lot of missing data and so forth? So here we can directly see that we have about 85,000 rows. So we work with quite a lot of data, right? 85,000 observations and 18 variables. We click on the down arrow and we can see here the names of the different columns. So season, okay, we know that we work with NBA, we know that we work with a team sport, basketball. So season is probably the season they play. Player ID, so we work with individual players here. We can see the name of the player and an attached player ID. So this is probably some way that the system which the data comes from identify the players, but we also have their name. We know their team. And then again, here is where your expertise in the field comes in. I know, for example, that these variables look more or less the standard way of saying the different kind of statistics that we have in basketball. So minutes, how many minutes did they play? How many field goals did they make? So how many of the shots from the floor did they make? How many did they attempt to shoot? How many three-pointers did they make? How many three-pointers did they attempt to make? How many free throws did they make? And how many free throws did they attempt? Rebounds in offense, rebound defense, assists, steals, blocks. So these are fairly standard statistics that you get in an NBA game or in a basketball game. So I feel kind of confident that I know what the data is about. I understand it. We can also check here which type of data are we working with. So most of them are numeric, but we have a couple ones that are characters. So text, we have the player name, we have the team, and we have minutes. And here, so this, again, when we are in this process of trying to look at the data and understand it, we think, okay, so playing minutes, here we should have a numeric value, right? I mean, if you play 6 minutes, that's a number. It's not text. But we can start to see here, we see the first couple of rows that we have it in the format of minute and seconds. So this player 18 minutes and 6 seconds, which isn't a valid format to put numbers in. So if we now, for example, would want to take the mean of this value, we're not able to because R recognizes this as text. So if we, for example, would want to do something with minutes, for example, how many minutes does a player play on average in a game, we would have to transform this data somehow before we can work with it. Next step is probably look a little bit more at the data itself. So we know which variables we work with, but we want to see a bit more of the data. So we can either click here where it says player data, or command click wherever it says the name of the object. When we do this, we get up the data in a data viewer, just as last week. And we say, okay, season, good. Looks like 2022. We could check, we could keep scrolling, but we won't do it in a file with 85,000 lines. We do see here that we have a bit of missing data. So this guy, Giorgio Deng from San Antonio, looks like he maybe didn't play in this game because we don't have any values. So NA is the R way of indicating missing data. So instead of just having it completely blank, we know that if the data is missing, it will say NA, which is good to know. We just look. So we have a bit of missing data. Apart from that, this looks kind of fine. Doesn't look like any super weird things. A good thing to check is a little bit, does the value seem to make sense? Like if here we have values like 1, 2, 5, 3, if we keep scrolling down a little bit, we shouldn't get any numbers that are 2000 probably, then we're having some kind of problem that we need to look deeper into. So this is just a little bit of a sanity check. Always look at your data when you import it. Just double check it. here we feel fine with this, so we're okay. First things first, we will work with how to work with rows. So in this case, we have a lot of rows. We might just be interested in some of them. We might be interested in arranging them different ways and so forth. The first function that we'll go through here is to filter. And again, we type filter, we see that it shows up, which might mean here, which means that we know that this is a valid function. It exists. If it doesn't exist, or it's in a package that we didn't load with the library function here in the beginning, we will not see it. Which means that this is another good way of getting a feeling for, okay, do I have the correct function? Do I have the package load, etc., etc.? And here we can even see which is the package it comes from. So we're fine with this. We tab to auto-complete it all the way. And again, we see here the arguments that are available is .data. Then we have ellipses, so 3 dots. We haven't seen this before, right? So again, best way to move forward always when you meet something new is put a question mark before it and run, or press F1. Okay, here we see that there is this function exists both in the dplyr package and within the stats package, which is one of the basic packages that are available always. For now, we'll just ignore this fact. We will look a little bit more into what happens with these things later on. But for now, we'll just accept that and click on this one. And here again, we have the help page for this function. And we say, okay, data, a data frame is what says first is what we will use most. Then we get into more advanced options, which for now, again, we will ignore. So a data frame, if you remember from last week, a data frame is an object that looks like this, where we have a bunch of columns with variables and a bunch of rows. So every time we see this kind of data that basically looks like an Excel sheet, we work with a data frame. So we see, okay, a data frame, the data frame we will work with is the player data, right? So we do .data equals player data, or again, in all of these functions that we are working with today, in all the functions in dplyr and a lot of other ones, the data frame is always the first argument. So we say, okay, this will be so common that we actually don't need to name it. We can just put the data frame in there directly. Then comes the next part, which is the ellipses or the 3 dots. And this is a little bit special version of an argument, because we read here, expression that return a logical value and are defined in terms of variables in data. If multiple expressions are included, you can combine them with that operator. So basically, every time you see these 3 dots, it means that you can enter arguments into the function that are not well defined here, that are not named here and have a specific function. In this case, the reason we want to do this is because we want to get only the variables, only the rows that fulfill a certain requirement, right? So let's say, for example, that we would only want the data from the 2022 season. All the older data we're not interested in. So that is what we do with these 3, inside these 3 dots. And to jump back quickly, so when we filter data, again, we have 85,000 rows of data, and we say we are only interested in looking at some of them. What we need to do then is to use logical operators. So this can be saying, I want to keep every row where this variable is equal to a certain value, right? Or to say when it's not equal to, or when it's larger or larger and equal to, smaller, smaller and equal to. And then we can start to combine these logical operators into having, so when this variable is equal to something and another variable is larger than. So these are the different logical operators that we work with when we filter out data. So we could do the first one. Again, we said, let's take the season, all the data where the season is 2022. So data equals 2022. We execute and we see that nothing happens. When nothing happens, or when what you expect doesn't happen, always go down and look in the error. In this case, we go down, we say, okay, there's an error in the filter function. In the argument data equals 2022, caused by error. So it's something wrong with my comparison here. And when I look at it, when you look at it, so now you say, okay, something is wrong. I need to go back and check what happened. Okay, the variable in the data frame is not called data, right? It was the season variable that we wanted to compare. So season, and now if we execute it, we see that, now it worked. Now we got what we wanted. We see that here we have a data frame with 14,500 rows. We have the same 18 variables as in the original data, right? But we have a lot fewer rows. Still a lot of rows, but a lot fewer. So we actually filtered out. So we only have the season 2022. We could also do not equal to. So let's say, for example, if we had about 85,000 observations from the start, and in the 2022 season, we have around 14,500. That means that if we now filter out and say, I want to take the player data frame, and I want to filter to only keep the rows where the season is not equal to 2022, right? Anyone dare to guess how many rows should we have in the new data frame? Yeah, okay. I know it's hard to do this interactively in an online class, but if we have 85,000 in the original and 14.5 of them were in 2022, we should get somewhere 70, just under 70,000, right? So again, we execute and we check, and yeah, we have about 70,000 rows. So again, we can work with equals, we can work with not equals, we could work with smaller than, right? So season smaller than 2022 in this case should be the same as not equal to 2022, because 2022 is the last season. This works. We could do larger than 2020. Then we see that we have about 50,000 that are in the season 2021 and 2022. So we can use all these logical operators to choose to keep only the rows that matches these logical operators. And we could combine these ones. So we could say, for example, that we want to keep only the data from 2020 and later. And, right, so now we start to combine. If this is true, so if C is season larger than 2020, if that one is true, and let's say that we want only one team. So when team equals San Antonio, so team equals San Antonio, and we execute and we run this, we see that right now we're down to 1,600. So we could kind of suspect that this was a success as well, right? So these are this is the basic function of the filtering. We could also do another thing. We could say that we want to have the teams. So if the team is if we skip the season and we say we want this to be when the team is San Antonio, so only keep the San Antonio athletes. We can run that and we get all the 2,600 rows. But we can also say or, and that's a straight line. So the straight line, or team equals, and we can take another team here. So Utah, or team equals Utah. If we execute this now, we should get all the data where the team is San Antonio or the team equals Utah. So this is how we start to combine things. We can use parentheses to do just as we do in math to keep to do in which order to evaluate these things. So we could start to combine these into pretty complex ways of filtering out. So we could, for example, say here that the team we want to have, we want to keep the rows where the team equals San Antonio and the season is equal to 2021, or the rows where the team is Utah and the season is 2022. So now when we run this, perfect. Next problem here. You see that down here, when I try to run this, it just gives me a plus sign. This means that something is missing in the argument, which in this case, most likely is parentheses. And you know, most of the time get a error message up here that will help you a bit. Okay, unmatched opening bracket. So we can see here that we can see this one. If you click just next to the parentheses, you see, okay, here this lights up this parentheses as well. So these ones are matched, right? We have the start and the finish. We take the next one, we have the start and the finish, but this one doesn't have a finish, right? So what is missing is a final parentheses. We do this. Down here now, we could just type the parentheses and run this down here. But since we corrected it in the script, so in the file that we are saving, what we can do down here is just escape to just say, don't run that. That was wrong. Let's skip it, forget about it. And then we rerun it up here again. So now we should have the data where team is San Antonio and the season is 2021, or the team is Utah and the season is 2022. Again, just as when we read the data here, we just see the first 10 rows, so we can't really evaluate did this work or not. And here it comes back to the same thing. When we create new data, so when we filter out data to only include the data we're interested in, we need to save it to an object. So here, for example, we could say that we have San Antonio, Utah data. Again, a good tip is use names for the objects that are that describe them, because all of a sudden you will have 20 rows here with different objects, and you will need to make sense of which one is which one does what. So again, I strongly recommend put names that you understand. As long as you work with data frames, a tip is to include data in here. And in R, the more normal way is to just keep everything lower letters and underscore where you would maybe normally put a space. So if we run this now, we see that we created this new object with only 1,679 observations and the same 18 variables. So we could inspect this if we click on it and look here and see, again, good to just do a quick check. Okay, so here we have a bunch of rows. Season 22 team is Utah. That matches what we wanted to do. Scroll down. We keep going, 2022 Utah. We have a bunch of data here, right? Keep going. San Antonio 2021, right? Okay, so it looks like we only have the data that we were interested in. Perfect. So this is the basics of how we filter out to get to only the data we want to work with. What happens here, though, just again, a styling thing. Remember last week we talked about this line. This line here is the recommended maximum length of each row. So what we want to do here is to start to break this down into several rows. The most common way to do that is, if it gets too long, each argument within the function goes in a new line. And here you will see that by default, it will be indented. So we will go a little bit inside. So we see that this belongs into here. Each argument, so after each new comma, we put it on a new line, and we end with a parenthesis that closes the function down. So this is just a way to keep the code easier to read. Now we have the data that we want to work with. So let's say we are only interested in San Antonio in 2021 and Utah in 2022. Next thing we might want to do with rows, again, always good to comment. So here we'll say, so we remember when we go back what we are doing. So we are here, we are loading packages. Here we are reading data. Here we are filtering rows. And now next step is, so when we work with the data, either for presenting or for ourselves to kind of start to look at the data in different ways, we might want to change the order that the data appears in. So what we want to do now is to order the rows. And the function to work with that is called arrange. So arrange, which is the data frame we want to work with. So let's say now that we were not actually interested in having all this data. We were just interested in having San Antonio 2021 and Utah in 2022. So we work now with this data frame, right? San Antonio Utah data. we even get a nice little preview of it just to double check, was it really this data? So once we have like 20 different ones, we can see, yeah, this looks like the correct one. Tab to autocomplete. And now, again, we can go to the help page. Always good, go to the help page, look. Arrange, here we see the same pattern again, right? Data comes first, and then we have the ellipses, the 3 dots. And we read variables or functions of variables, and use descend to sort variables in a descending order. So since this one, the arrange function, orders the row in the data frame based on the columns we're interested in. So what comes here is which is the columns or variables that we want to order this data based on. So if we look here, let's say that we want to start by having we want to see which was the one that made the most shots, right? Field goals made. So how many shots they shot and made. If we now put FGM and run this, we will see that, okay, field goal made, all of a sudden the order changed, and we have now in order. So field goal made, the problem is that we start to count from down to up, right? So we see here all the ones that are 0. And if we save this into another data frame, so let's call this San Antonio, Utah, arranged data. We save it so we can look at it. If we check here, here's the arranged data. We look at it and we see, okay, field goals made, all the ones with 0, then comes all the one with 1, then comes all the ones with 2. So we're just resorted, we just changed the order of the rows according to this variable. If we want to do this the opposite, we read in here in the help. So, okay, use this desc to sort a variable in descending order. So what we do is we just put desc for descending around. And if we run this now and look at the data, we see that it changed. It's the opposite. So we start with 15 is the maximum amount of number of shots that someone made in the game. So perfect, we get this to work, right? Now we want to be able also to work with arranging after several variables, right? So we have, okay, there's 2 games where someone made 15 field goals. And then we have 2 with 14, and we have 4 here with 13. But inside these ones, they just show up in the order that they showed up in the original data. So now let's say we want to see who made the most shots, but inside the same number of shots made, who shot the least, right? So the more shots you make in the fewer attempts, the better. We go back, and now we will add another argument. So remember, the ellipses, the 3 dots, means that we can add several. In this place, we can add several different arguments after each other. So we say that we want to sort first by field goals made in descending order, and secondly, field goals attempted. So if we run this now, look at the data, we will see, okay, field goals made 15, field goals attempted 18, 15, 26. So again, we see that it's ordered first by the field goals made and then by the number of attempts. We can check here where we have more. 12 made, 15, 18, 20, 21. Okay, perfect, this works. So this is a way to work with arranging data in a certain order we want. This could be good, one, for checking a quick check just to see which is the maximum values, which is the minimum values of different variables. But after we get this down to fewer data points, and we want to maybe present this to someone, it's a big help to be able to put it in the order that we want. This is ordering the rows, and we'll look at one last one before we take a short break. And this one is find distinct combinations. So another thing that we might want to do is to say, okay, but we sorted out, we filtered out only keeping data with 2 teams. We might want to double check, is there actually only these 2 teams in the data? So what we can do now then is to say distinct, which is the name of the functions to just get down to the distinct data. Data goes first. We work with San Antonio UDA data. San Antonio UDA data. Perfect. If we just run this function with the data, which is perfectly possible to do, we will get each row that is completely distinct. So where it will just only delete rows if 2 of the rows are completely identical. So the value inside every variable, every column of these 18 in this case, are completely equal. So when we have a complete duplicate of 2 rows. If we check here, we have 1,679 observations, rows. Observation is row. If we just run this, we see that we get 1,473, which means that, yeah, there was some duplicates. There was some rows that looked exactly the same in this data. So this is a very good way if you think, so let's say that you get data, for example, from someone that has been typing in manually, and you say, oof, but maybe they put that guy in twice. Then this is a good way of just clearing that out. But what we can do with this one is to define, so which of the variables do we actually want to look at? So if I could run this only with season, for example. And what will happen now is that it will only look at, it will say, okay, we only look at the season variable, and then we take out all duplicates. So what we are basically left with is, which are the unique values in this variable? So in the San Antonio UDA data, in that data frame, all the values that exist in the season variable are 2022 and 2021, which in this case makes sense, right? Because we said that we specifically filtered out only some of the ones from 2021 and some of the ones from 2022. We shouldn't have any other variables here. If we now, for example, would do the same with the original data, so we change San Antonio for player data, and we run this, we see that in total there were 3 seasons in the data. So 22, 21, and 20. We don't keep, when we filtered the data, we didn't keep any of the values that are from the 2020 season. And we can also do this with combinations of variables, which is where this starts to be really useful. So we might say, okay, which are all the unique combination of a season and a team? And again, here we could, since we specifically filtered out some of them, we know which combinations should exist. We should have only the combination where the season is 21 and the team is San Antonio, or the season is 22 and the team is Utah. And this is correct. So this, for one part, is a good way of double checking that we are getting the data that we want to get, right? But we might be interested in more things, so not just what we are actually sorting on. So let's say we want to know who are the different players that we keep in this data set. So we can say that distinct, the San Antonio Utah data set, but we want to know who are the players. So we have player name because we understand that better. And now we'll get, again, a data frame. A table is a kind of data frame. So when it says table, that means data frame. We get out the data frame with the variable player name, and we start to see the first ones, and we see, there's 40 more rows here. So in total, there's 50 different players. And these are the different players that we have. Again, we could save this and say San Antonio, San Antonio, Utah players. We save this. And now we have here San Antonio, Utah players. We click on it, and here we get the full list. So we can scroll all the way and check. Okay, good. This might be very interesting for some specific reason. That depends on what you are actually doing, obviously. But we can also here say, maybe we don't just want to know the players. We want to know the team they play in. And then again, we can work with several variables at a time. So we could say, which are all the unique combinations of a team and a player? We run this. Again, we save it into an object. We can look at it. And here we see now we have the two teams, and we see which of the athletes are in each team here. So this is how like getting the data down to which are all the distinct variables or distinct combination of variables. A very similar one that basically does the same, but it adds a count. So we might say one thing that we were interested in was, okay, so what was the unique combinations of team and season? But what we actually might want to know is how many rows do we have for San Antonio in 2021? How many rows do we have for Utah in 2022? And for that, we use the count function. The count is basically the same as the distinct one, but we add just an n in the end. So an n indicating how many rows do we have. So we try again. San Antonio Utah data. And we want team and season. So instead of just knowing the unique combinations of team and season, we want to say how many rows are there for each unique combination of team and season. When we run this, we see, okay, San Antonio 2021, 1,139. So we have 1,139 rows in this data that is from San Antonio for the 2021 season, and 540 for Utah for the 2022 season. If we go back to the data and think about this, okay, so what does this n means? What are we actually counting? So we look at the data and we say, okay, each row, so each observation is what? Is a player and a game, right? So each row is Lauri Markkanen played 29 minutes and 15 seconds in one game. And then we keep scrolling down. Here we see Lauri Markkanen again in another game. So this 1,139 rows mean, okay, we have 1,139 times a player appeared in a game. And this is another important point when we work with data in this way, that a lot of times we have to sometimes go back to remember, what is an observation? Is an observation an individual? Is it each time an individual appears in a game? Is it each time an athlete does something? So we could have the data with one row for Lauri Markkanen in a certain game, the first shot, then it comes the second shot, then it comes the third shot, right? So when we work with data frames and we have data, especially when we are not the one that put the data in from the start, we need to have clear what constitutes an observation, what counts as a row. So these are a couple of functions to work with the rows. Hope some of you at least were able to hang on. I suggest we take a 13-minute break. So at 10:15, we continue and look at more of these ones. So I will pause the sharing. I will pause the recording, and let's see in 12 minutes. Resume the recording. Okay, I know it's quite a lot, so I'm just throwing a bunch of functions on you here. We'll try in the last part today just to little bit show the full picture again, how you might work with this and how you might work with these ones together to actually create something interesting. Again, the idea isn't that you should grasp completely these functions at first sight. The idea now is that you've seen them, you've had some experience with them, and then you go back Monday and you work with these by yourself a bit during next week. So I will just keep going at rather fast pace to get through, and then we'll try to look at the full picture, and you'll just experiment at home. That's the pedagogical approach to this class. So we looked a bit at the different ways we can work with and changing rows. So how can we keep only the rows we're interested in? How can we get them in an order we want? How can we look at only distinct combinations of them? Now we'll move into looking at ways to work with the columns, so with the variables, because oftentimes when we get the data, it's not that we can just present it, plot it, create a table directly. We might need to calculate some. We might not be interested in all of them, and so forth. So we'll look at two main functions for working with columns. And the first one is called mutate. So what we will want to do here is calculate new variables. So the next function is mutate. And again, it looks the same. We always, in these functions, we always start with the data, and then we tend to have the ellipses. So where we put like the arguments of what we want to actually change in the data frame. These ones tends to get long. So again, for good practice to keep the code readable, we can suspect already from the start that we'll need to put them in several rows. Another thing that we will that you will probably use quite a lot is what is called the pipe. So again, all of these functions starts with the data argument. And when we start to write here, for example, it might be a little bit hard to see, okay, so which is actually the data and which is the variables we're working with. And we can always, for a function, pull out the first argument, which tends to be data, and put it before the function. So for example, this function, instead of saying we want to take distinct from this data and these variables, we can write this as data, then pipe. This is called, and it's in Mac is Command Shift M. On Windows, I think it's Control Shift M. And then you just automatically insert these characters, which is a vertical line and a larger than. You could write these ones by hand. So you could do just vertical line and larger than. The Command Shift M is just a shortcut. And what we do here is we say, take this object and put it into the first argument in the next function. So instead of saying we want to take all the distinct combination of rows in the San Antonio UDA data for these variables, we say, take the San Antonio UDA data set and put it into the distinct function, right? And this, when we just use single rows, this might not seem that much of a help, but once these start to get longer, and this also means that you can start to combine them, which we'll see after. So this is called the pipe. Command Shift M or Control Shift M will be really useful. So we'll start with that directly here now that we work with mutate. So we say San Antonio UDA data, and then pipe, and the normal way of doing it, unless it's really short, is now new line. So to keep good coding practice, new line, mutate. And again, now we've pushed San Antonio UDA data. We pushed it inside the function as the first argument, which is the data argument. Perfect. Now, mutate works by always saying which is the new variable name we want to create. So which new column do we want to create? Equals how we want to calculate this column. So we could do something as easy as saying we want to create a new column that is called X, and we want this column to have the value 1. Right? So here we could call these San Antonio UDA calculated data. So if we take this data and we just create a new variable X and it's equal to 1, we create it, we look at the data. By default, they show up in the end. So after the last column that you have is where you get the new ones. You can change this with before and after arguments. I will not go into them, but when you look at this yourself, if you look at the before and after arguments, you can choose kind of where these columns show up. And then we see column is named X, and the value is 1. And the value is 1 everywhere, which might not be that interesting most of the times, right? This is generally not what we want to do. Somehow we want to calculate things based on the other values in the rows. So if we go back here and think, one thing, if we talk about basketball, we a lot of times want to know the shooting percentage. So we know how many shots they made, we know how many shots they attempted, but we want to know what was the shooting percentage. So of the 10 shots, how many did they make? Again, we want to keep kind of the same style of names so we can go back and remember. So we just don't call X is a horrible name, because then when you worked with this and then you come back a week later and you watch it and you say, what the hell was X? So again, good names that makes you understand the meaning. So in this case, if we might want to calculate field goal, so field goals were the shots, right? Field goal percentage. PCT is a common abbreviation for percentage, right? Okay, how do we calculate this? Well, in this case, it's easy. How many shots they made? So equals field goal made divided by field goals attempted. This is how we calculate a percentage. We try, we calculate it, we save it. We look at the calculated data. And we see here that now we have a new column with a bunch of values. We could just, good practice is just double check a little bit if it makes sense. So we have here 7 out of 14. If we calculate that by head, okay, so it's half. So this should be 50%, right? Or 0.5 if we talk about decimal form. Makes sense. Next one is 1. Okay, one shot, one made shot on one attempt. That's 100%. That's 1, right? Makes sense. Perfect. Keep scrolling, looking a bit. We see that the one that didn't have any, that only had missing data. Probably this is a player that for some reason didn't play in the game, which means that they didn't make anything inside the game. That's my guess based on expertise in basketball. We see that then if we have a missing data in the variables that is calculated from, then we have a missing data in the variable that we calculated, right? Since we don't have data on how many shots or misses, we cannot calculate the percentage. And then we have one more thing. We have NaN, and this stands for not a number. And this shows up, this can show up sometimes. And this means that whatever calculation it tried to make didn't result in a valid number. And if we look here at, okay, 0 shots made and 0 shots attempted. So what we tried to calculate here was 0 divided by 0. And again, high school math, we know that you can't divide by 0. Okay, so we can't get a correct number. We can't get a number of this. So perfect, makes sense. That explains why it's not a number, because it's not a valid number. Let's say now that, okay, we have it in decimal form, but we want it in real percentage form, right? Like we want to go from 0% to 100%. What we do, we need to multiply by 100, right? We could do that as well. 100 times field goal made divided by field goal attempts. We run it, we check the data. And now we see that we have it perfectly here in 50%, 100%, 71.42857%. Perfect. So this is the basic of how the mutate works. Now, you can do a lot of things with it. And this is something that you can read. If you go into the book, the introduction to our data science in R book, you will find more examples, more how to work with this. I'll just show you quickly so you've seen it and know about it. One thing that is important to know here, though, is that you can calculate multiple variables at the same time. So again, for good practice, we put it in a new row. So we knew that here we wanted to calculate the field goal percentage. But we might also, if we look at the data, say, here we have field goal 3, M unattempted. So these ones are field goals behind the 3-point line, right? So a specific type of shot. We might want to calculate the percentage for these kind of shots as well. So then we just do the same, field goal 3 percentage. What is this equal to? Well, the same, 100 times field goal 3 made. And again, you see here when we work with these ones, you will get the variables to show up here. So when you see this one and you see which one it's on, tab and you autocomplete it. Divided by field goal 3, and here we see now we go down to attempt, tab and autocomplete. So now if we run this and we check the calculated data, we see that we calculated both of the two new variables. So you can do this for multiple variables at the same time. The only thing is each of these ones, so new variable name equals and how to calculate the new variable is an argument. And between each argument, we need a comma. So a normal problem here is that you finally start to do more and more variables that you calculate. And then all of a sudden, you forget a comma somewhere. And you try to run it, and it says error, unexpected symbol. Okay, then we see here that we get a little bit of help when we read the error messages. Okay, we see here field goal percent, da 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 da. So it's somewhere around this line where the problem is. And again, RStudio helps us a lot of times with these crosses. So here it helps us to say, okay, we should have a comma here. So we add the comma and now it works again. This is the basics of how these things work. The nice thing here is that you can use the columns that you create, you can directly use them. So you don't have to calculate them in mutate here. And if you want to use them again, do that again. So we could take as an example, let's say we want to calculate what is the ratio between how many rebounds a player take and how many shots they shoot. Okay, so do a player shoot more than they take rebounds or the opposite? We go into the data, we look, we have OREB and DREB, which is offensive rebounds and defensive rebounds. And we have the field goals attempted. So these are the three variables we're interested in. We could do this in 2 ways. We could either just say we want the rebound field goal ratio. And then we say we want to take offensive rebounds plus defensive rebounds, right? Because we want all of the rebounds, so the total. So we want to sum up this and that. Perfect. And we want to divide it by how many shots did they attempt. So field goal attempt. And here, if you remember math, in which order do we make calculations? So we make multiplication and division before addition and subtraction, which in this case is not what we want, right? We want to first calculate this total and then divide it, instead of first dividing defensive rebounds with field goal attempts and then add the offensive rebounds. So we need to work with parentheses. This is one way to do it. And if we run this and we check the calculated data, we see that we get this ratio. right? So here we see that here, for example, they took 4 times as many rebounds as shots. So Jared Vanderbilt shot 1, took 0 offensive rebounds, 4 defensive rebounds. Makes up 4 times as much. Perfect. But we might also actually want to know how many rebounds did they take in total. And so the nice thing with the mutate function here is that we can say we want to calculate the total amount of rebounds, which then would be offensive rebounds plus defensive rebounds. And then instead of doing the same calculation again, we could just say we take rebounds divided by field goal attempts, even though it didn't exist in the original data. So even if we calculated inside the mutate, we can reuse that variable again. So if we run this, check the calculated data, we see that we have the number of rebounds in total and the ratio. The only thing here to keep in mind with a mutate is that you can only use new variables that you define after you calculated them. So we can't do the opposite here. We can't take this line and put it afterwards, because we're trying to use the variable here, but we're creating it afterwards. So when we try to run this, we get an error, and we see here, okay, in the argument rebound FG ratio, so we know that it's somewhere on this line that the error occurs. Object reb not found. Okay, so this object is not defined yet. This is why we need to do it before. A small tip and trick here: if you hold, you can move lines around without copy pasting. If you on Mac do Option, and I think on Windows is Alt, you hold it in and you just do button up or down. And that one didn't show up on my here, but Option or Alt, and then you can just use the up and down arrows to just move a line around. So if you notice that you had the wrong order, Option or Alt, up and down to move it to the right place. So this is how we create new variables. We can do this without creating new variables. So we could do this just redefining one of the variables we have, which oftentimes is not good practice. We should avoid it, but it's possible. So what we could do here is to say that we want the offensive rebounds to be equal to the amount of free throws attempted. Okay, this is very bad, right? We don't want to just overwrite the values we have, but so you're aware of it, if you put a name here in that already exists in the data, you will just override it. So if we now check, if we now calculate and we go to the calculated data and go to the offensive rebounds, we see that in every row is the same as the free throw attempts. So here it hasn't created a new one in the end. It has just changed the one that already existed. So you need to be a little bit aware of this to not risk to overwrite anything and do stupid things. Okay, so next step is we've calculated these things. We calculated the new variables and so forth. Let's say that we're not actually interested in all the variables we have. So now we have this and we want to present this to the coach, to our supervisor when we do a thesis, to whatever we want to do. But we look at the calculated data and we have 22 variables and we say, are all these ones actually relevant? Like we just wanted to look at the field goal percentage. That was the only thing that we are interested in knowing. That's what the coach wants to know. So we want to select relevant variables. And this function is nicely called select. Easy as that. So now let's say we want to work with this calculated data that we had. So again, we will use the pipe, San Antonio range data. San Antonio calculated data. So I go down to that one. Perfect. We have the 22 variables. It's the correct one. Tab to autocomplete. Command-Shift-M to do the pipe. New line. And now we want to use select. So here we can already, without having to always go to the help page, we can get some information already in the yellow boxes. So we want to keep or drop columns using their name and type. So we select which ones we want and which ones we don't want. And then you have more detailed information, so we can do a bunch of different things. But basically what we do here is select, and we put the names of the variables we want to use. So let's say that we only wanted the field goal percentage. We might want to know which is the player, right? Or if we look here at the calculated data. Okay, season. We might want to know which season we're talking about. Comma, next argument. What we have more here? Okay, we have player ID. If we show this to a coach, they will not know what the hell we talk about. Player name, yeah, that's good to know. Player name we want. Team, might want to be interested to know which team they play on. And then we see here, these things, are we interested in it? Are we interested in it? No, the only thing we wanted was the field goal percentage. So we put field goal percentage. And now if we run this, we see the preview, since we didn't save it into an object, and we see it only keeps the variables or columns that we chose. So this is a good way to just get the data down to what you are actually interested in. You can do this by choosing. You can change order. So let's say that we actually don't want the same order as we have in the data frame. We want this in another order. That's fine. When you use the select, it just shows up in the order that you choose it. So we could do, we want player name to be first. So we want to first know the player and then the season. And if we run this now, we see that we get the variables in the order that we selected them. We can also, let's say that here we've calculated these new variables and we are interested in getting most of this information out, but we want to keep everything except the player ID, because the player ID doesn't tell us anything, right? So what we can do then is, instead of choosing which variables we want to select, we can choose the variables we don't want to select, the ones we want to take out. And that we do by using a minus before. So like minus, we want to take out the variable or the column that is called player ID. And if we run this now, we can see here, okay, same order because we didn't tell it to change any order, right? Season, correct. Player name. Here we see we don't have the column player ID where it was supposed to be. So this is a way we can either select which ones we want, or we can select the ones we don't want. Yeah, question?
If we wanted to select the players that have a percentage, field goal percentage over 50%.
Yes. Good. Let's actually do that now. So what we can do is we can start to put these functions together, right? Then we are back to filtering, right? Because we are saying we want to choose which rows to keep. So select is working for which are the columns we're interested in, which are the variables we're interested in. Like here we say, we are not interested in the player ID. That doesn't matter for us. So which of the columns should we take out? And we looked at filter in the beginning, right, as a way of choosing which are the rows we are, or observations that we are interested in. Now we can start to put these ones together because, for example, we calculated some new variables in the San Antonio UDA calculated data. So now we want to say we want all games where a player had over 50% field goal percentage, right? This is something, it was not in the original data. We had to calculate it first. But now, once we have it, we can just use that data instead. San Antonio UDA calculated data, right? Is the one we just, where we have the percentage. We use this one, and now we want to filter. And when we filter, it's always, we choose the argument, we choose what we want to keep. So we want to keep all the rows where field goal percentage is larger than 50. And we might say, like, we classify this, we know that this is good shooting. So if it's over 50%, this is good. So we might say, now we want to save this into good shooting data. We save it. We can just look here. Good. We have San Antonio UDA calculated data, 1,679. Good shooting data, we filtered, we should have fewer rows. Good shooting data, 480. So here we only selected the rows we are interested in looking at. And if we go in and look here, we see we have all the new columns we calculated. And we see here that field goal percentage looks like it's always over 50, right? So this is one way to do this. However, if we start to do this, like go step by step in these things, every time we want to get some information, finally we will end up with a lot of these objects. So, and here's the nice thing with the pipe operator. So the little bit arrow where we push into something. Because here we can say that now we know that this is what we want to get. We get the data in, and we just want to see which is all the games where a player scored over 50% of the shots. So we say that let's forget about all this other. We've read the data, and now we're working with, or let's say we know that we only are interested in these two, San Antonio in 21 and UDA in 22. Okay. Now, we wanted to know where all the games here. So let's say that we actually don't have all the other data that we calculated saved this way. And there's a nice way to do this, to make sure that you are not working with something that comes later in text when you're jumping up and down in the script, as I just did. Like I was down here, calculated all of these things, but now we want to do something before that. And we want to make sure not to reference something that will come after, because that will give us problems. What we do then is we restart R. And the command for that on Mac is Commando Shift R. No, sorry, Commando Shift 0. So when we do Commando Shift 0, we restart R. And here's the other problem. And this happened last week also. Finally, we get this back here. We don't want this, because again, now we can reference things that we don't define until later in the script. So what we need to do here is to go edit and go to the settings or preference in Windows. And we want to make sure that we also have, we don't want to restore our data into workspace. No, we don't want to save this. So we click never. Okay, and now when we restart R, we see environment is empty. So now there's no any risk that we start to use data that we didn't define yet. So again, we have to start from the start. Commando enter, we run the loading the packages, loading the data, filter out only to work with the data that we're interested in, which is this data. And now the nice thing, what we do with these functions is we start to build them on top of each other to get to where we want to be. So we want to use the San Antonio UDA data. We want to calculate a new variable that is field goal percentage, which in this case is equal to, we said we wanted in percentage, right? So in 0 to 100 instead 0 to 1. So 100 times field goal made divided by field goal attempt. If I just run this now, is a good, like, just run to make sure it works. We check here, and if we look down here, we say, okay, we don't see it here, but that's because it only shows us the columns that fit. If we look down here, we say, okay, 4 more variables: blocks, turnovers, personal foul, field goal percentage. So we have it in the data. And now instead of saving this to reuse it, we can just pipe it directly in. So now instead of taking the data, the data frame we have saved, we say, take this data frame, calculate this, and with the new data frame that you have with this calculated, we want to filter. And now we want to say where field goal, we want to keep the rows where field goal percentage is larger than 50. We run this and we see that we have fewer rows. So good. We might think, okay, do we actually want to have the ones that are more than 50%, or do we want to include the ones that are 50%? Okay, we say 50% is fine, it's still good. So now we go back and we say, okay, no, not bigger than 50, bigger or equal to 50 is good. We see, we got a couple of more rows. So we got what we wanted, what we were looking for. We could save this now to good shooting data. So we could save this and check the good shooting data. Check here again, field goal percentage. We calculated the variable and it looks like we filtered on it directly to only get the ones over 50 or equal. Next tip is when we are working with kind of these multiple steps at a time and want to just try our way forward and not like this is final, this is what I want to have. An option, instead of saving it all the time and opening the data frame, we can just do another pipe into a function that is called view. And what this one does is exactly the same. So when you click on a data frame here on an object, what it actually does is run the function view. So again, if I click here on player data, you see that what it actually runs is view, the function view player data. That's what makes it show up here. So we can do this directly. We've calculated, and instead of saving it into an object, we just want to see it directly. So we pipe it into view with a capital V. And now if we stand anywhere inside, since these ones are all connected, doesn't matter where we are in this row. When we run it, it will run all of it together. We see it ran all of it together, and last step was view, right? So then we got the data here directly. Good, perfect. We have what we wanted. So we only want the good, like the good shooting games, but again, we don't have any order to it. We might want to see, but we wanted the best shooters. So everything over 50 is fine. We might just want to double check, did it work? We might check, and which game was the best shooting? So again, we can take the filter. We don't need to save it. We just push it directly into arrange. And now we arrange it by field goal percentage. And by default, it goes from lower to higher. Again, we do the pipe to get it into the view. And now when we run it, we get a problem. Error. So again, this error doesn't help us that much, right? Error in view, in argument, blah, blah, blah. Okay, we don't really know what this is about. But we know there's something wrong. And if I go back here, I see, okay, field goal percentage, but here I didn't use the more common way, PCT, to abbreviate it. I said PCG, and then I forgot about that and wrote PCT. So again, these kind of errors happens all the time. It's normal. So they will happen, and it's just to go back and correct it. And it happens to everyone, even the best ones. The important thing is being able to see that it's an error, see if there is any help down here, and then go back and look at the data. So we actually want all of this to be PCT. Now we run it, and we get up the data, and we see that we have all sorted by all the ones. So 50% comes first, then, and here we still have a lot of rows, then going up, going up, going up, going up. Perfect. And we might want to say, okay, instead of going from 50 to 100, we want to see which games was the absolutely best. Remember, inside the range, we could put the variable inside descending in the desk to do it in the opposite order. I show it, and we see, here's a bunch of people that had 100%. So they made all the shots they shot. Good, good. Perfect. There's a bunch of them. And then we say, okay, are these ones the best shooters? Are these ones the ones in the games that shot the best? And we might now start to go back and say, okay, how many shots did they actually attempt? So we see here, Jared Vanderbilt, in this game, he made one and he shot one. And we say, would we really say that he's the best one at shooting in basketball because he made 1 of 1? Like if he would have missed it, that would have been a 0. So we might oftentimes want to say, okay, but they need to have shot at least 3 shots in the game to be able to count. Everything less than 3 shots is like, it's so few that the percentage isn't really correct. Like it's correct, obviously, but it doesn't give a view of how good did they shoot. So again, then we go back to the same data again, and we think, okay, how do we achieve this? Okay, we want to keep the rows where the field goal percentage was higher or equal to 50. And like, it's not enough to keep a row. It's not enough that it's only 50% or higher in the field goal percentage. We also need the field goal attempts to be higher than 2, right? We said more than 2 shots. So now we are going back in the same code, complementing it. So this is the iterative process of trying something, looking, realizing, okay, we need to go back and mix something up. Then we go back, we look at this again, we change it, we run it again, and we see, Okay, we still have a bunch of players with 100%. It looks like there's less of them. And now we see that everyone shot at least 3 shots. So now we might be able to say, we have Walker Kessler here has 1, 2, 3, 4, 5, 6, 7, 8, 9 games where he shot at least 3